Welcome to tonight's first IoT North live stream. We're trying something a little bit different. I'm sure we'll have some faux pas, but hey, we'll have a bit of fun with it too. Thanks very much for joining us. We've got a great lineup with Ricardo from AWS, Steve Hilton from Machnation, and we've got our updates on manufacturing from Mark Weymouth as well. And we've got John Staveley supporting me, so thanks very much for that, John. Okay, so tonight we also got the announcement on the IoT North Marketplace that the registrations for the use case marketplace went live today. So I'll give you a little bit of insight on that. But let's start with Mark. Hi, Mark. How are you doing?
Hi, I'm good, thank you. I'd like to say it's a nice sunny day, but I guess it isn't now. It was a nice sunny day.
It was. We had a nice bit of sunshine up here as well, which is a nice change. So, Mark, what's been happening in manufacturing?
Well, trying to keep with the spirit of things being positive in manufacturing, despite what you don't read in the mainstream media. I thought I'd pick a couple of pictures. And hopefully, instead of seeing me, you're seeing a screenshot with some moving images. Okay, so things that happen, most importantly, hot off the press, the PMI index is positive again. So that's 9 months of manufacturing growth. Okay, it might be 9 months from a low point, but it's 9 months of growth. Things to that have happened over the past month. An interesting statistic I picked up was the UK is still number 3 in Europe for the automotive industry with 30 automobile factories. And for example, BMW's UK Hounslow engine plant is celebrating 20 years. For some of us, myself included, it's very scary to think that's 20 years. Britain, the world is on the cusp of the electric vehicle revolution, and certainly the UK is positioning itself to be workshop of the world for EVs. So let's see what happens. And let's see if JLR's announcement during the month of moving across to EV and their new strategy takes us in that direction. So enough about the car industry. Hey, I might be trying to appeal to a Northeast England audience, but there's a world outside of cars. Talking IoT, interesting to see MTC commit to a purpose-built 5G private network aimed at really signposting for industry how to adopt 5G and IoT within the marketplace. Going to another extreme of manufacturing, but celebrating what's great about Britain, Cadbury's chocolate. Okay, might not be great on a world perspective, but on a UK perspective. February saw the shift of a lot of production from Europe back to the UK and back to Birmingham for Cadbury's dairy milk. So there's something that's close to my heart, nothing else. Coming towards the end of some flavours, what happened in the month? A lot of employment. The Engineering Centre of Excellence talking about creating 200 highly skilled jobs. Again, automotive bias, I'm afraid, on that one, but a lot of employment throughout the year. And other examples would be 200 jobs for Shawshire for COVID testing, 850 jobs in Leamington Spa for diagnostic work, and the food industry. The boom of the past year continues to boom with Two Sisters announcing 500 new jobs in February. Back to manufacturing, penultimate sort of item I picked up really was the massive employment in the UK by BAE Systems and their announcement with Rheinmetall working on an armoured vehicle for the British Army going forward. Latest announcement, £180 million to Thales for the next 10 years on a visioning system. Talking British Aerospace, or BAE Systems, as we're now meant to say, as part of my pushing the space industry. Interesting to see BAE announce £21 million profit and announcements again this month of new projects and investments for space industry. What else happened in February? Most important thing, perhaps underreported, but I'll bang my drum, was to see National Apprenticeship Week and lots of stories about the importance of apprenticeship, something that maybe's taken a hiccup and will be knocked back by COVID, but hey, I really try and push out news articles about apprenticeship as well as engineering STEM. So that's a flavour of the month, lots of positive news. I would encourage anybody, if you want to hear something positive on a Friday, follow me on LinkedIn. Let me tell you a little bit about what's positive about the UK and manufacturing. Any other day of the week and even Friday, contact me if you're all interested in sensors, as I will try and help make sense of sensors. That's the month.
Excellent. Thanks, Mark. Some great news there and some great progressive things coming through. So it's nice to see the country hasn't come to a stall quite as much as we're all sat in our homes here in the UK, and we do have Steve there in the US, who I think they're having pits and troughs of that, aren't they? Okay, so next we have, as I mentioned, the announcement that the IoT North Marketplace went live for you to register your use cases. What is it? Well, with the support of Newcastle University, we've launched an equal opportunity marketplace, which basically what that means is removing the branding and just focusing on the use cases and the solutions. So if you've got a solution, IoT solution, get it registered on there. We're going to attract the lead generation and bring the businesses to those solutions, and then they simply connect by clicking a button, filling out a small amount of details, and we'll send an automated email to introduce you both. So we're helping you really push forward and drive the adoption of IoT. If you check out iotnorth.uk website, look at Solution Marketplace, there's a lot of information there and the links to register as well. And I'm sure I will be slipping through some information about it throughout tonight's session. Okay, Ricardo, hey, how are you doing?
Hello, and yeah, I'm doing great, thank you.
Brilliant. So, Ricardo, what exactly is your role at AWS?
So I'm an evangelist for open source at AWS.
Nice. A bit of a thing that I like to try and do for AD-Link
Indeed.
here as well, in engaging with developers to get the best out of adoption and drive moving forward. What's the coolest IoT solution that you've been playing with?
So I think it's probably my current project, which is a bit of a labor of love. I've got 2 growing children, and what I tend to do is try and kind of reanimate these toys they used to have. And they had one Christmas one of these kind of candy claws that you kind of, like when you go to the fun fair and the claw comes down and it kind of picks up a sweet. So I've taken the electronics out. I put a Raspberry Pi in there. I can now control it, through AWS. And my next move, which is kind of like to my topic today, is to create a simulation environment, create a reinforcement learning agent, and then hook it up to my Alexa so I can say, Alexa, get me a sweet, and then the claw will then grab me a sweet. So very much a work in progress, but it's a lot of fun.
Excellent. So I think this leads on quite nicely to your talk. So I'll just bring your screen in here, and you can fire away.
Brilliant. Okay, well, listen, thank you very much again, everyone, at the IoT North for this opportunity to speak with you. The session today is really about how building intelligent robots. So I've already talked about my Claw project. This was one of my first projects. I'm just going to play this very, I hope this works. This is an old remote control car. This is a project I did about 4 years ago. I was trying to teach it to drive itself. And as you can see, this is probably about as good as my driving is in the real world. So not too bad an effort. So what I'm going to be covering today is, in the next 30 minutes, is walking through some of the use cases around robotics, some of the fundamentals around what robotic operating systems are, and then I look at how we can actually then use cloud services to add intelligence into those. And there's going to be lots of demos. So hopefully I'll have enough time to go through all of them, including hopefully one that's going to work, which is very topical, which is how we can use AI to find Martians on Mars. So let's just hopefully we can see all that. And I've got to share lots of resources. Okay, the QR code for the link there is there, but I think you've also got the link you can share with folks viewing.
Yep.
So I want to start off, first of all, is actually defining what is a robot. And for us, the definition of a robot is the kind of 3 things. First of all, it's something that can sense. Once this robot has sensed something, it can compute, and then based on that computation, it can then act. And robotics is an increasingly growing kind of market. And if we look at some of the kind of the industry analysts and market data, we can see more interest. But talking about use cases, what you said about the marketplace, increasingly it's not just a few narrow use cases. It's lots of different use cases now that are getting in on the action. In fact, yesterday, one of my colleagues, if I just hope this is going to work. One of my colleagues, he lives in Northampton, and he got a delivery from Co-op from this robot.
No way.
So, this is very much, something that a lot of organizations are beginning to experiment with. Okay. But, following on from that, so we've got this growing interest in robotics, and it's working in lots of different industries, and there's lots of growing and emerging use cases. But robotic development and developing the software as well as the hardware is still has been challenging, and it's been challenging around kind of like these 5 areas. So the first one is when you created a robot, it requires lots of different expertise along different areas. So you need, mechatronics, navigation, mapping, computer vision, simulation. All these different domains have to come together when you're developing your robot. The second thing is that the actual software tools and hardware tools you need are very diverse. And so setting up the development environment, the tooling you need, making sure it's updated and secure can be tricky. The third one is that typically, when it comes to the physical hardware, you've got a broad selection of components you can choose from, as well as kind of like the physical assembly of those. And that takes time. It typically takes a long time to actually do the physical part of robotics. And then once you've actually, kind of got to the situation where you're ready, then actually how you then deploy and maintain and manage fleets of those robots is, something that, you need to think about. And then kind of like the final one, which is, is my screen not sharing?
It's okay.
Okay.
I'll bring it back.
Okay, cool. Then the last one is actually then how you kind of like do this iteratively, right? So you create V1 of your application. How do you create V2? And typically, this is what we see as the kind of the typical life cycle of a robotic application, where you select your software frameworks and components, you develop the application, you then test, train, and simulate the application. That becomes an iterative process until you're ready to deploy and manage that application. But you're not just looking at just V1 of that robot application. You want to add more features as your customers say, this is great, but can it do this? And so with all that, one of the open source projects that's emerged to kind of like tackle these problems has been ROS, which stands for the Robotic Operating System. Now, I'm not sure how familiar people are on this group are with ROS. Is this a topic that's been discussed before or comes up?
It's not, but I am personally aware of it because AD-Link DDS is within ROS 2.
Okay,
I've worked
cool.
with Joe Speed, who's an active evangelist around this.
Yeah, yes, indeed he is. Yeah. Okay, cool. And so just for those people that aren't familiar with it, it sounds like it's an operating system, but it's not. It's actually a middleware, and it comes in 2 flavors: ROS 1 and ROS 2. ROS 2 being kind of the current kind of modern version, but still there's a lot of stuff being done on ROS 1, and kind of the version of ROS has got these kind of funky names. So Kinetic, Melodic, Neotic for ROS 1, and Dashing, Eloquent, and Foxy for ROS 2. And these tend to be tied to versions of Ubuntu that you're running. And so the current version, Neotic and Foxy, are the current recommended versions you should be using. Now, ROS 1 and ROS 2 aren't directly compatible, and there's work ongoing, and AWS actually is heavily involved in that, and creating tooling that helps you migrate a lot of the ROS packages from ROS 1 to ROS 2. But actually, when you look at what actually ROS is, you can think of ROS. This is a very simplistic kind of like view of how ROS works. Is you have this concept of nodes, which are kind of application kind of packages or functionality, and these kind of like these nodes communicate with each other over a kind of like pub sub bus. So in this very kind of simple diagram, I've got a node that represents a light, a camera, a wheel. And if, for example, the wheel wanted to, brake, it would send a message to the brake node, and the brake node would then action. And so you package these things up, and then you have kind of like a namespace, which is called the ROS master, kind of which kind of manages it all together. And kind of ROS provides kind of all the tooling to do the running, the packaging, the building of those nodes. And what's happened is over time, there's been this kind of over the last sort of many years where academia, researchers, and now increasingly more commercial organizations have started kind of using ROS. There's this kind of growing library of node packages that you can use, and you can kind of like think of an equivalent of this as kind of like your npm or your PyPy or your NuGet, where you've got these kind of like software components that are readily used, and obviously open source plays a big part in that. So when we kind of like look at ROS, and kind of how it kind of works with kind of solving the problem of developing kind of a robot. We kind of like, use the kind of the ROS software to kind of develop the application, but then it also provides tools to actually kind of like deploy your application in a simulation, so that you can actually then do things like test to make sure that your robot does what it says. Now, what we're effectively doing here is we're applying kind of modern software techniques to something that traditionally was very physical and very labor intensive and took a long time. So now we can create a robot in code. We can create the environment in which that robot's going to operate in code through using various tools, creating kind of like 3D models which have physics engines and are rendered so that they look like a 3D world. And you can actually now start kind of automating and applying tests to that to see actually how that application is going to function on that robot. And you have this kind of this concept of like a low fidelity testing to high fidelity testing, where low fidelity testing is actually when I assemble this robot in this environment, does it actually, does it move around and do what I want? Or a high fidelity testing, which allows you to go down to the level of, are the motors on this robot, is it within tolerance of vibration or heat and that kind of thing. And so where ROS kind of like kicks in with kind of like the kind of IoT, is typically once you've created this kind of application, the robotic hardware will typically draw upon many of the IoT capabilities. And so here, for specifically, I'm looking at kind of like the kind of AWS capabilities around, fleet management, over-the-air updates, how you securely provision those robots, and then how you roll out these updates to your robot fleet. So you wouldn't necessarily roll out your new version of your robot application to all your robots. You'd have a strategy whereby you would deploy to 10% of the fleet, and if 1% of those fleets were failing, you'd then stop the deployments. So it allows you to then kind of like kind of apply software, modern software techniques to the process of kind of rolling out your fleet. Okay, so that's enough talking. I really want to show you actually what some of this actually looks like up close and personal. So I'm going to just switch. Sorry.
No, just saying. Excellent. Looking forward to it.
Yes. All right. So let's. First of all, I want to show you what a typical. Okay, you can see that. I'm not sure if it's going to be big enough. So let's see how I can make this bigger.
I'll make it bigger. There you go.
Fantastic. Good stuff. So if we look typically at kind of the layout of a ROS application, and this is a kind of a typical standard, you have this kind of concept of a workspace. And here I've got a robot workspace with a standard set of folders and a simulation workspace. So simulation workspace will typically contain kind of like the objects of the environment. So it might have a model of a chair or a table, and we'll look at more of that in a minute. And then we've actually got the robot workspace, which will contain the code of my robot. Now, in this first quick demo, I've got a very simple robot that doesn't operate in any environment. And we've created a node, and this node just takes a existing package. I remember I talked about these packages being available. So this is a turtle bot, and we can look at the turtle bot. Where is it here? So here it is, the turtle bot, and we can actually see this is the actual package itself, and we're going to use that, and we're going to create a node that's going to send a command on that message bus for it to rotate, to twist around. So let me just now let's see, make sure that the demo gods are with us today. I should have everything prepared. So we've got a number of commands. So ROS launch is the command that we actually use to launch the application. And here what I'm doing is I'm selecting my workspace. So here it's hello world robot, which corresponds to the folder here, hello world robot. And I hit return, and it's going to start launching the robot. And now I'm going to create a simulation environment. And it's now going to spin the simulation world environment, and it should hopefully bring up a tool called Gazebo, which is a modeling tool. You can see that this robot is now kind of like rotating very slowly. It's very, very boring, but we'll come up to more interesting demos in a bit. Now, Gazebo is the tool that you would typically use to actually create your your terrains, your worlds that you want to test your robots in, and it has all the sort of typical things you can do. You can like add objects, obviously. You can create more sophisticated objects. You can join them together, create joints, and then this obviously works with physics engines, so you can do things like drag and gravity and all that kind of stuff. Now, what I'm going to do is just show you very quickly is that you saw that robot turning one direction. Just to show you how this works, is if I wanted to make the robot turn a different direction, what I can do is I can just change this value here. I can save it, and then I've got to run a command, which is one of the tools that you have when you're working with ROS applications. So I'm going to go into the robot workspace. I'm going to do a colcon build, which is one of the build tools that's available in ROS 2. But when you're using the AWS RoboMaker service, which is a managed service that provides ROS, we use colcon as well. It's now built that update. I can now rerun this application, and we should see the robot turning in the different direction. So we'll see hopefully if that works. Nope. It's not, and I know why, because I didn't save the file. I was doing this earlier on, and I had exactly the same issue.
I love a live demo.
Yeah, and there we go. Let's have a look. Let's do that. Yes, they say that your IQ falls as well when you're doing live demo. So let's have a look. Come on. All right, let's do that. Let's try that again. And hopefully this time it will turn. It will be a different direction it's going in this time. We'll see. Going left last time, and it should be going right. And here we go, it's going right this time. So you can see very, very quickly, but that's kind of like a bit of a boring demo. Let's try and make this a bit more interesting. So let's just close this. And let's close that. Wait. I'm doing this over VNC, and I think sometimes I've got the machine literally next to me, so I could actually just literally turn over, lean across and stop it that way. Right, okay, so that's kind of a very simple one running on my local machine. Now, what we can do is we can actually do something a little bit more interesting. Okay, we can actually put a simulated world in here, and I've got a different application. And in this one, it's got, again, it's using the same robot, the same turtle bot, but it's got a standard nose which will make this robot navigate through a random path within a predetermined environment. And that environment, if I look at here, where is it? Where is it? Nope. It's in the depths. There it is. It's in here. So we can see here we've got a ROS package that's called Small House World. And when we look at it, we can see there's a number of different things in here. So we've got a folder which contains different assets such as chairs, tables, carpets. And we're going to use this, and we're going to launch this just so you can see what a bit more of an interesting project looks like. And with ROS, there's a number of different tools you can use. So I've used Gazebo as the kind of 3D modeling tool. This tool is one that allows you to actually kind of take a peek at actually the robot running. So again, this is still virtual, right? We're not running anything physical yet. This is still virtual, but we still got the same capabilities as if it was a real robot. So here we can actually now, we can see some of the sensors from this virtual robot that's operating in this virtual environment. We can see that in this is the actual world it's running in. It's a little apartment, and we can actually see the robots. Let's zoom out. And we should be able to see the robot moving there, and we can see the kind of the bird's eye camera view of this what this robot's doing. And as it navigates through the building, or the apartment, sorry, what it's doing, okay, is actually creating a map of this. So if this was our sample application or a sample robot, then we can now, before we've even put one soldering iron on the table, okay, we've now actually tested to make sure this application is going to work. Right, so let's just stop this one here. And again, at this stage, what I'm doing, okay, I'm doing everything on my local machine. So I'm not running in the cloud at the moment, okay? I'm running everything just on my local Ubuntu box here. But, if I wanted to kind of do this at scale, right, if I wanted to do and test hundreds, if not thousands of robots, maybe I've got, different types of layout of apartment or maybe different textured floors I want to do it. I need kind of like cloud scale to do this. And so this is where we need a service such as RoboMaker. So let's take a look at that. And so let's have a look at this. This is the one. Yeah, this is the one. Okay, so this is the AWS RoboMaker service. It's a service that provides you tooling as well as some kind of extensions to ROS that allow you to make it easy to kind of integrate your robotic application into the cloud and use services such as storage, logging, the kind of CI/CD and testing, but also, which is what I'm going to come to in a bit, kind of the intelligence capability. So, some of the AI services such as visual recognition, or speech. So, for example, you can get your robot to speak. Now, I'm going to actually launch the robot here. Now, what I've done is I've made a little customization to this one, and what I've done is I've actually changed the one of the pictures in here to be a to have the logo of IoT North. So let me just try and get that up if I can find the command. Where is it? Okay, GZ. Got to find the one. I think it's this one here. Okay, so what I'm doing here, okay, is I'm actually running a kind of the sim application in the cloud. So what you saw before when I was doing it on my local machine, I was running some commands. What RoboMaker allows you to do is simplify that, so you can actually kind of create templates and then rerun those templates by cloning them. And actually, if I show you through the IDE, we've got the files like I showed you on VS Code, but you also have the capability within the actual IDE to provide some capabilities to your builders to make it really easy to build, bundle, and then launch simulations, so you can actually test. And that will allow your your robotics developers to be more effective and create your robotic applications more quickly. So let's just make sure that's coming. So it's launching now. What you'll see here is, as it's launching, we can see some of the things around how this robot is going to integrate with the cloud. So we've got security integration, we've got metrics and logging information, as well as storage information. So this robot, as it's connected to the kind of the network, will automatically have that integration into the cloud. Now, this typically takes a few seconds. Let's have a look while it's going on. And this robot is now up and running. So again, I can use the same tools as I showed you, the gazebo, which is the 3D world, and then the RQT. We'll do that. So let's have a look. And that. So we can see here, we've got the gazebo world again. And we should see the robot moving around. Oh, where's it gone? Oh, there it is. Now, what I want to show you is somewhere here we have where is it gone? We have, there it is. We zoom in. It can be a bit fiddly. We can actually see that the logo of IoT North is on the wall of this building. Okay, so it's quite easy. What I did here, if I just stop this demo running, is if I use the world here, those artifacts I showed you, those models. What I did is I actually changed the artifact in there to have an updated photo, rebuilt it, republished it, and then my model was ready to go. Okay, so like I said, if you want to do this at scale and test this against hundreds or thousands of robots, one of the things that's really nice about RoboMaker is it allows you to use what's called World Forge to automatically generate as many worlds as you want, given a set of rules that you create. So here's one I created. These are all apartments of a certain type, different flooring, different layouts. I can now spin up 10 simulations and get my robot to go through that, do whatever it needs to do, and then feed back through the logs. So I can now see, does my robot work on all these different types of environments? So I'm not going to, just for the purpose of time, I'm not going to show that demo, but I do have that one running, and I've got all the links that I'm sharing with you. So you can run that yourself if you're already using AWS. It should be quite easy for you to get that demo up and running. Okay, so that's kind of like just a quick overview on what RoboMaker and ROS is. Let's now look at the kind of the next piece, which is the intelligence piece. So let's look at, where's my mouse gone? Here it is. So yes.
Sorry, we've just got a question from David at Bellina. Hi, David. Good to catch up again. Is that world open source? Can we grab that from somewhere?
So thanks for the question, David. So there are a number of the assets that I'm sharing today are available on the AWS Robotics GitHub. So you can, yes. There are also within Gazebo. There's lots of packages that you can also start from scratch. So sorry, you can reuse, so you don't have to start from scratch. So I'm sharing some of those resources, and the ones I'm sharing today, including the JPL Mars rover one. These are all open source, so you can use those as a base for your own projects. So if we look at kind of machine learning and AI robotics, so really there are two kind of aspects to this, okay? On one level, we've got AI services, and these are pre-trained models that have got limited scope for customization. You typically access via an API, but you don't need any AI or ML expertise, but you do need some connectivity, which means that you can use those to do things like, here's a picture from my camera. What is it? What can I then do based on that picture? So I could create a robot, for example, that looks for a particular object and then maybe follows it. And that's all great, but what if your robot is offline or in a harsh environment with very poor connectivity? Then you really need to run your model in kind of a standalone kind of edge model. And this is where you then need to look at actually training and building your own models. And typically what in the robotics space, reinforcement learning is kind of like one of the strong approaches. And reinforcement learning, for those that may not be familiar with this, is where you have an agent. So typically that's the robot that has a set of actions it can do. So it might be the wheels that make it move, the arms it's got, and that operates in an environment. So that's where your robot actually is, your simulation. And then you give it some kind of a task, and that task is rewarded. So the idea is that, if you want a robot to pick up a box, you will create a reward function that rewards it when it picks up the box. And then what happens is that reinforcement does thousands and thousands of iterations through that process. It generates data. That generated data is used through batching and randomizing to go through a training process, which then gets deployed on the robot, and then you can actually then use that in an autonomous way without requiring the connectivity. And I've got a very quick demo at the end of that to show you how that actually works with a fun project we created called Deep Racer, where we've got everything running in the cloud and simulation, but we've also got physical remote control cars. You take the model on a USB stick, plug it into the car on a real racetrack, and it goes around, hopefully, with a good track time. Now, one of the things that once you've got your model, you need to be really kind of conscious of is, typically on robots and on devices, they're very sensitive to power and compute. They're typically low power and they've got limited compute capability. So you need a way of optimizing the machine learning model for the environment that it's going to be operating in. So a couple of years ago, we launched this service called SageMaker Near, which is open source, based on TVM and Treelight, that allows you to compile against a number of different source frameworks to a number of different target architectures, and it generates really super small, super efficient models that allow you then to operate on even really low power and low CPU devices and still run those models with a high degree of confidence and rating. So now let's just do a couple of quick demos on AI and ML in robots. I'm going to use the same kind of environment we had just now. So I've got a simulation which is a person detector, and what this does is it takes the apartment we've got, the same. What it does is it's streaming the video from that camera that I showed you before into one of our AI services called Recognition. So this is all, it's all managed for you. And what we've done, actually, if I show you the notebook, I'll show you the actual click. So we've got a number of images. There's 10 images around. So this is Doug. And what we've done is using a very simple piece of code, we've created what's called a recognition collection. We've added his face, as well as, I think, where is it? Here, a number of other faces with their names. We've added that to the collection. It's now incorporated that into the collection. And we then publish that as an endpoint, which means that what we've now got the ability to do is when a picture that has got a high level of confidence, and I think we've selected the confidence rating of 85%, it's going to say, haha, I've spotted this person's name. And actually, a few days ago, I posted on the LinkedIn post, if anyone was brave enough to send me a picture, I was going to use their picture in here, but we didn't get any takers. So never mind, we'll do that maybe next time. So let's have a look. So has this started yet?
Ricardo, just to let you know,
yes.
we are good for time.
Oh, okay.
The challenge has been cancelled.
Oh, it has. Oh, yeah. Okay. I'll slow down
now.
I'll slow down. Okay, cool. Thanks for letting me know. Right, so we've got this person detector. It's up. So let's now do things we've. So we're going to use RQT. So these tools now, again, I've not shown RQT yet. So RQT is another tool that Ross provides you. And here it has a series of plugins, and we can look at things like the camera. So this is the camera feed. It's also got a really funky little tool, which I like, which is a robot steering. Now, which we might have to use to try and get it to behave itself and move towards people. And then we're going to run up a terminal. RQT, there we go. All right, so now what we need to do here is I've got a couple of commands I need to run. So let's have a look. Okay, so the first command is going to change the time, and then the second command is going to look at one of the topics. So I mentioned that there's a message bus. These are topics. You can actually use a command called ROS topic, call list, to actually view all the topics. So this is all the various nodes and how you can communicate with them. And what we've got here is we've got the ability to echo. And in this particular one, it's actually the way the architecture works is as the robot is looking around the apartment, it's streaming the video to the recognition service. When the recognition service finds one of those pictures we've added to the AI model, it's going to say, aha, I've spotted someone. Well, at least that's the theory. And look at that, we found Renato. I'm so glad that worked. And we'll leave this running because it's going to potentially. Oh, there's Doug. We've seen Doug. Please see Doug. Oh, it was too quick. This is where sometimes I've had to slow the robot down and try and go back. We'll leave this running because I want to show you the next demo. So let me just move these around. So that's a demo of kind of like working with an AI service. But reinforcement learning is a really important kind of machine learning approach with robotics as well if you want to do offline. So this is Deep Racer, and we've created a reinforcement learning model. And what we can do here is we can actually test this model against a racetrack. And again, this is something you can do yourselves. And what we should see in a few seconds is the robot that I trained earlier on with a reinforcement learning agent start to drive around a racetrack. And whilst that's waiting, there is another model I've got here, which is again, it's a reinforcement agent. And it's this time the robot, it's a waffle robot. It's been put in a maze. And this morning I trained it over 3 hours to figure out how to escape from the maze. So I'm hoping that was enough time for the model to be effective, and we should be able to see that model. If I go on to, it's still starting here. It still hasn't started yet. Okay, well we'll come back to that in a second. This is still starting. So there's a lot of stuff that's running here in action. Let's go back to the department, see if we can see any more people. So it's seen Sean now, but you get the idea, right? We're basically adding intelligence to the robot really, really easily. I've not had to be a machine learning or data scientist to do this. I've just made some API calls using an existing ROS package that I can incorporate within my robot application. And very, very quickly, I've now incorporated the ability to do some kind of visual recognition. Hopefully it's going to see that person. I'm not sure who that is, but hopefully the AI will tell us. Is it Sean? No, that's Brandon. There we go. So you saw that action. So I'm going to shut this one down now because I think you get the general idea of that one. This one is, I'm not sure what's going on here. It's here we go. So this is now running. But
sorry, Ricardo. Sorry, Ricardo. You may have said it, and I may have missed it. I do apologise.
Yeah.
But what inferencing are you running for the vision side of things?
So the way what's happening is that the camera through a ROS node is integrated into a service called video kinesis video streams. So basically, it's just feeding as a raw stream, and then that's plugged into a collection which we've created in the notebook with the faces. And so what happens? The way that works is that as the video is being streamed through, when it detects something it knows, it then puts on a different cue, a different topic, the name of the person it's found. So effectively what you've got is you've got one stream going from the robot to AWS, that's the video stream, and then you've got another data stream going from the robot to the cloud, but this time listening for messages on that queue, and those messages are the names it recognizes. Right. So that's how the architecture works. Now, as you can see, whilst I was talking, my attempt to get this racing car to go past that to do a lap was awful. Let's hope that the maze one is better. We'll soon see. Oop. Oh, geez. Let's try again. Right, there we go. Oh, it's actually nearly. Oh, this is looking good. This is looking good. I think we've caught it just at the right time. Don't let me down now. Don't let me down. So look, it's navigating. It's navigating. So let's zoom out. So it starts off here, and as you can see, it's supposed to go to the finishing line. And again, this is a very simple world. It just crashed. So, but you kind of get the idea. And now I could deploy this model on a robot with no connectivity, and it would know how to navigate a maze by just using the input from the camera. So this is an example of using reinforcement learning. This one is using the open source Coach reinforcement learning ROS package. There are others out there you can use, and it's deployed in this instance the simulator, but you could deploy this on a robot, on a waffle robot if you've got one. And in theory, as long as your maze looked similar to this, it should be able to navigate. Right, so last demo. Okay, hopefully this is going to be the best one. Going back to this one is finding Martians on Mars. Okay, so here we did a workshop last year, and we had a challenge with the NASA JPL folks around creating various reinforcement learning agents to navigate the rover through Mars. And so there's a whole bunch of fun projects out there. This one particular is a simple project that has a bright green Martian. You have a rover. And then you navigate, and the idea is you see if you find the alien. So let's go and get this up and running so you can see what it looks like. Again, there's a number of this one, because this is running completely locally, so you can run this one yourself locally as well. In fact, actually, all of the projects I've shared today, you can actually run yourself. And what I've got here is I've got a script that actually shows you when it's seen an alien. Right, so okay, and what it's doing is it's just tailing a file we've got on the cloud. We can see our Mars landscape, and let's actually start RQT. So we want RQT. What we want to do is we want to basically navigate this so that we can actually. So let's start driving. And hopefully my bad driving is going to go faster. So what we're doing, this one hasn't got an automated. I think I'm going completely the wrong direction there. Yep, which is not too dissimilar to real life. Thank God for sat nav. That's all I can say.
Just imagine this is exactly how NASA are doing it, Ricardo.
Yeah, exactly. That's right. So we can see I'm getting there slowly. Come on, you can do it. And again, these assets you can use yourself. They're all available. So now what I'm going to do is just zoom out. Okay, so now let's see if we can go turn around. Now this rover actually can't go in reverse. I'm not sure if that's the case with the real one or just this one, but this one can't. So I'm hoping I can turn around and get a nice full picture of the alien. Okay. Right, now let's get that text. Can we see the alien? Where's the text gone? That's not that one. Okay, so this is the text. So let's move closer and see if the AI can kick in and see if it can see it. So at the moment, it's not thinking it's a Martian. Come on, you don't let me down. The demo so far I've worked okay. You can do it. You can do it. Come on.
Come on, everybody, make a prayer.
Come on, you can do it. Surely you can see the alien. Oh, hang on, I've got a message here. I can see this is obviously getting. That's typical. I thought this one would work. It was working this morning, and for some reason it's let me down. Oh, there it is. Found an alien. Found an alien. So that's the last demo I've got. So it works. So I'm happy. I'm happy it worked. I mean, these are very simple, fun demos. Like I said, the source code's all available. To share. And I think that I just want to finish off with a couple of kind of customer stories. So that's kind of like all the demos. So hopefully it's giving you a bit of a feel for kind of like how you can. So what ROS is, some of the capabilities. How ROS and the cloud work together, some of the challenges that ROS helps roboticists solve. I've shown you some demos, some simple demos that you can use as the baseline for learning and doing some other things. But real customers are using this, to solve challenges. So we've got with the apartment example, anyone who's got one of those automated vacuums. they're using the fact that you can run concurrent simulations to help them improve the quality of their robots. We've got other customers who actually using this environment, these testing tools to help develop and prototype their tools. I've shared with you the example from NASA JPL, and interestingly, there, one of the use cases there for kind of the ROS was to help develop the robotic arms that that go on these kind of lunar vehicles. And to kind of like what we're also doing is we're finding some interesting things working with some of our education partners. So here are some of the kind of education partners. I'm just going to show you a couple of videos here of what they look like. So here is Arizona. I'm not sure if you can hear the audio.
If you no, you need to share the video link, I think, rather than playing it through.
Oh, okay, right. It's to be honest, the audio is not really that important. Basically, what this is showing is the fact that they're developing a robot, a dog, to help the blind using the ROS tools that I've showed you, and another example here, which I show you. Where is it? Run. Oh, where is it? Here we go. And this is basically where they're using Alexa to wake the robot up. So they're saying, Alexa, wake the robot up. And then the Alexa is going to basically, first of all, they say, Alexa, what's the status of the robot? Alexa says it's sleeping. Then it says, Alexa, wake the robot up. And then the robot wakes up. And obviously, if you think about it, with robots, there's no user interface. So voice is the natural user interface for robots. So that's one of the reasons why having AI services such as voice is really important when it comes to developing your robotic applications. So that's me done. I finished my demos. I finished what I came to talk to you about. If there's any questions, then I'm more than happy to take them.
If anybody has any questions, please pop them in comments, and we'll get them brought on screen for Ricardo to answer. David T, if you've got any more, you've asked some great ones. Ricardo, that was absolutely awesome. I think for our first live stream, I think you really smashed it for us out the park in such an engaging and really, really interesting insight there. So this has been absolutely brilliant. Really, really enjoyed it.
I appreciate that. Thank you very much.
And we've got some good feedback from there, Mr. Stavely as well, kindly as well. Ricardo, thanks very much. Really appreciate that. Mr. Hilton, how are you doing, sir?
Oh, I'm doing great, sir. How are you?
Feel a little bit of pressure?
Oh, yeah. I mean, I'm going to have to sort of go from Mars and bring it back to Earth, which, there's no way you can win on that one, right?
Hey, I'm sure everybody will find Machnation and your talk especially interesting. Steve, it's always been a pleasure to catch up with you, and we caught up a couple of weeks ago leading to us moving on to the talk. I was just very interested from our conversation about the impact of COVID with the IoT adoption. I was wondering if you could share some of the insight.
Yeah, I mean, I think it's a really great question. It's sort of the question that pretty much every enterprise has today. I mean, I think there's a couple things going on in the IoT world. COVID has sort of refocused people on sort of different kinds of solution and sort of redoubled efforts. So if it has anything to do with sort of tracing where sort of people are, so treating a person as a thing, that's very sort of popular solution these days. Location-based solutions, remote monitoring, remote control, sort of ways to sort of get people sort of more spread out. Those are very popular things. That's the first thing that's happening. And I think the second thing is that every enterprise is rethinking what its sort of business continuity and disaster recovery strategies are, right? With respect to technology and all of its processes. If for no other reason than they probably didn't think about global pandemic, right? As part of their BCDR. Right. And I think now what they're realizing is, okay, IoT is part of our technology fabric. We can't have IT be sort of devoid from our BCDR strategy, right? How do we make sure that IoT matches what we need to do with resiliency and reliability in the other parts of our technology? I think that's what's going on.
Yeah, I mean, from my chats with users and builders and such like, and especially with industry leaders and verticals as well, the there seems to be this huge awakening of, oh, that's what digital transformation means, which then leads on to the how does IoT fit into their digital transformation? You know, there's an awful lot of view with certain businesses and verticals that digital transformation was having a website.
I think
They're
it's
actually
true.
realizing now it's actually the business processes and how you can enable and automate
I
and
think so.
start to put autonomy in there as well. I think that leads quite nicely onto your talk.
Yeah, as I was saying, are you able to share the screen, or
Yeah,
do I
I've
need
got it
to?
there.
Okay, cool. Okay, well, yeah, I mean, as I was saying, I think, I'm going to sort of bring us from Mars back to Earth, and maybe even another example or another way to think about it is I'm going to take us from the world of these really cool examples that Ricardo talked about, each one so cool in this sort of in the flat, in the apartment, and on Mars, and bring us to sort of the world of how do we get stuff done from cool examples to sort of production level scale. How do we make things actually happen and work at sort of high scalability and high resiliency and high reliability? And I think the question I would pose today for everyone on this live stream and everyone in the IoT ecosystem, is 1 9 of reliability enough in IoT? 1 9, not 5 nines, not 4 nines, 1 9. So what does 1 9 mean? Well, it kind of means, imagine a world where sort of 90% of the data gets from device up to the cloud into a platform, right? Through sort of the implementation of whatever IoT platform you put in place. Or 90% of queries from an application north of a platform, right? Querying the IoT application, querying a platform, 90% of those queries are successful, or 90% of sort of the data for an analytics workflow pulling out of an IoT platform is successful, right? Or 90% of IoT device alarms, an alarm goes off on a device, 9 out of 10 of those get delivered. Is that good enough? Well, the dirty little secret is that's where we are today in production scale IoT. That's really where we are. And this is not the case of sort of the underlying IoT platform from a hyperscaler or from a sort of an IoT solution provider provides sort of 1 9 of reliability. But these platforms and these software stacks have to be configured. They have to be stood up for a given customer implementation. And when they are, generally where we end up is about 1 9 of reliability. And so that's what I'm here to talk about today, bringing us once again from Mars back to Earth, which is how do we drive high resiliency, high reliability into IoT, into a world post-COVID-19 where business continuity and disaster recovery matters. It matters in the IT technology world, and it certainly matters in the IoT world. And I'm going to talk today about this type of high resiliency and reliability. I'm going to talk today about IoT performance testing and how do we use tools to actually test IoT software stacks at production level scale and make sure that they can perform with more than 1 9 of reliability. So just as sort of a heads up, so Machnation, we're a software and services firm. We're specialized in hands-on use and benchmarking of IoT platforms and end-to-end solutions. So we literally use IoT software ourselves in our test lab. And this gives us really deep insights into what the software itself can do. We're based in Boston. We're in our 8th year of business. And as I was saying, we run our own IoT test lab, which makes us kind of unique. We call the test lab Mighty, M-I-T-E. And in our test lab in Mighty, we help enterprises do 2 things. One, we help them architecture, design, and select an IoT platform stack. Right, so this is the stack that's sort of everything from the device up through sort of the northbound, so to the northbound side, right, all the way up to sort of the IoT application. And we do that by actually using all of these platforms ourselves, which gives us really deep insights into capabilities of these platforms and into the UX of these platforms, the architectures, and all this other characteristics. The second thing we do in our test lab, which is what we help enterprises do, is we help them tune and improve the end-to-end IoT solutions that they've built. And how do we do that? We use IoT performance and scalability testing software. We literally simulate IoT devices, like for example, like Ricardo's devices, robots, we would simulate those at production scale. So instead of just having one sort of in a lab testing against an IoT platform, we can actually simulate 10, 100, 1,000, 100,000, million, 100 million, right, in our software, right? And we have the software create all the types of workflows that are typical in IoT. And this helps enterprises tune and improve their IoT solutions. So today, as I said, we're going to be talking about performance testing. And if you want more info about performance testing, you can hit me up at one of the venues in the top right corner of all these slides, either at the info@machnation.com or in our machnation.com contact page. And happy to get you some more information about this really cool area of performance testing specific to IoT. Also, if you want to just download the slides, you can go on the website. I think the guys put it up at machnation.com/performance4. You can grab it there. And there's lots of other information on our website also about performance testing for this piece of software that we built called MightyPF. And I guess just a little plug for AWS. So we built MightyPF to be strictly IoT performance testing software. And Ricardo, we built it all using AWS services, completely infrastructure as code, 100% serverless from the start, which has been just incredible, being sort of that close to sort of AWS services and being able to use that technology. So small, I mean, we didn't plan that today, but it just so happens that we're in AWS. That's what we use for our software. Okay, so onward to the good stuff today that I'm going to be talking about. So the agenda, we're going to talk about what is IoT performance testing, what is it, and why do enterprises do it? Secondly, we're going to talk about what are the top 5 performance tests for the Internet of Things. So there's tons of performance testing that goes on today in the world of like websites, right? Like if you have a website, performance testing of the website, that's a totally common thing. It is not common in the Internet of Things. We do this for large industrial enterprises through our test lab. So we're going to share with you what are the top 5 performance tests that these enterprises are doing in IoT these days. Thirdly, we're going to talk about what is needed for best-in-class IoT performance testing software, and then just a few little resources at the end if you want to learn more about IoT performance testing. So IoT performance testing. So let's start with what is it? I don't have to explain to folks on this live stream about the simplified sort of an IoT technology stack. It's pretty common when I do this presentation in other places, I do. But suffice it to say, you've got devices and sensors at the bottom. Maybe they communicate to a gateway, maybe they don't, right? You've got a connectivity protocol layer, that's usually over MQTT, sometimes over lightweight M2M, HTTPS, various connectivity protocols leading up to sort of a platform layer, right? And we usually refer to that as an application enablement platform. Sometimes we call it an IoT device and data management platform, right? So that's sort of the cloud layer. And then above that, you've got some kind of application, and that can be, it could be a dashboard, an IoT dashboard. It could be like a little analytics workflow that's running sort of on top of the platform. It could even be sort of a mobile application that's or a tablet-based application that's running in a factory, that's checking, that allows a technician to be able to see how the equipment's running in a factory, right? That's the application layer. And there's 2 types of sort of performance testing that happens across this technology stack, right? So firstly, there's data and workflows. Number 1, there's data and workflows that go from devices and sensors to the platform and back to devices, right? These workflows often run over MQTT. Sometimes they go over lightweight M2M, they go over HTTPS. So that's the first kind of performance testing that happens, is to make sure that the data and the workflows can get from devices and sensors up into the cloud and back to the devices and sensors if needed. The second kind of performance testing that goes on is sort of the northbound side, right? So it's queries from the application layer, often via HTTPS, to the platform itself, right? So as I was saying before, it could be the case of, a factory worker on a factory floor, checking a dashboard to see how, the various equipment in the factory is working. Could also be you and me we've left our home and we want to see if any of our connected lights were left on, or to see if we left the connected garage door open, right? We would have an app on our phone or on some other screen that allows us to query to the cloud to see what's going on with the digital twin. So those are the two types of performance testing that we routinely do at Machnation. Why do enterprises do performance testing? Well, not surprisingly, they want to be able to offer extremely resilient, reliable, performant IoT services to their customers, right? This allows them to prevent unplanned IoT system problems. And frankly, it also allows them to offer credible IoT SLAs to their customers. Well, not only credible SLAs, but also profitable, because at the end of the day, they want to be able to set up an SLA with their customers that they can meet, because if you don't meet an SLA, of course, you get dinged and you often owe cash out the door, and they certainly don't want to do that. Another reason that enterprises do this kind of performance testing of an end-to-end IoT solution is they don't want to over or underspend on the infrastructure or their platforms that they use to manage their IoT software stack, right? You don't want to overspend on your infrastructure, because who wants to spend more than you'd have to on that? And they certainly don't want to underspend on your infrastructure, because then if you do it, you really are running into performance issues, right? If you don't have the proper level of infrastructure to support your IoT software stack. And finally, enterprises are doing this kind of testing so they can beat their competition. They want bragging rights. They want to be able to show that they can, push, that their software stack, their solution is capable of, supporting X millions devices and doing, tens of thousands of digital twin updates per second. Like, that's good stuff, right? It's sort of bragging rights that sort of matter in sort of the enterprise software world. So that's what performance testing, IoT performance testing is, and why enterprises do it. As I was telling you before, the way to ensure that the software stack that an enterprise puts in place is capable of meeting its SLAs, of sort of being more than 1.9 reliable in performance, is to do performance testing, right? And enterprises test their IoT end-to-end stacks to drive this resiliency and the reliability into these end-to-end solutions. And there's 5 tests they do. And I'm going to go through these really fast just to share them with folks on here, but just a sort of quick definitionally. So message ingest, that's really pretty common, right? So that's data going from the device into a platform at scale. Digital twin update is the devices successfully being able to update their digital twins on an IoT platform. Queries to simulate a mobile IoT app, that is, as I described before, is some kind of app at the top being able to issue a query to grab data out of the platform or out of the digital twin. The 4th test that we do, we call a mass disconnect or reconnect event. That's kind of like a disaster, if you imagine, right? So it's like a lot of devices all of a sudden disappearing off a platform and then reconnecting all at once. So what happens? What happens to the platform? What happens to the software stack when that happens? And finally, the last one is a mass firmware or software over-the-air update to simulate that at scale. I think actually Ricardo was talking about that earlier, sort of drawing the connection between robotics and IoT being sort of that software vehicle to be able to control a device, or also to be able to sort of push out updates to a device. So we simulate those. These are all totally typical aspects of every single IoT solution. Data coming in, data being queried out of the top, making sure that if the disconnects happen, that devices sort of gracefully can reconnect and the platform can recover, right? And being able to do a photo and SOTA. These are typical IoT things that happen in every single IoT solution. And these are the things that enterprises test to make sure in the production environment that they can drive to more than 1.9 of performance. So let me go in just a little bit into each one of these. So the first one is message ingest. This is the most basic testing that we do, that every enterprise we work with tests to make sure that the device can deliver its data to the cloud, to its IoT platform, to an IoT platform. This is usually it's data going over MQTT, a little bit here and there. We test over lightweight M2M, certainly over HTTPS. Why do enterprises do it? Well, it's important to know the efficiency of this most common IoT workflow. And to make sure that we understand things like what is the sort of message failure rate over the course of a 20-minute test or a 24-hour test. How many messages make it into the platform and how many don't, right? What's the latency? What's the average latency of those messages and how long it takes to get from device into platform? And finally, sometimes devices just randomly disconnect from a platform and we don't know why. So our simulated devices on MightyPF, our platform, don't disconnect, but sometimes the platform will disconnect a device for random reasons. And it's really important to be able to track how many disconnects happen, when, and why. So that's the first kind of testing that we do to help understand the efficiency of message ingest. The second test that we do is updating a digital twin. Once again, the device updating its digital twin, its digital representation, its online representation of itself, right? And this is almost always done over HTTPS. Enterprises do this to understand and to know that the device updates its digital twin with its current state. Because if you think about it, IoT applications northbound, right? So whether it's someone's smartphone checking their garage door, or checking their connected lights, or it's the guy on the factory floor checking the condition of machines. When he uses his application to check on the status of the machines, or you check on your garage door, your application certainly is not querying the garage door. No, it's querying the digital twin, that digital representation in the cloud layer in the IoT platform. So if your device is not updating your digital twin properly with its current state, the garage may be open, the garage may be closed. No one really knows for sure. So we test it, right? We test it at production level scale to make sure that the platform, the digital twin updates are happening properly. So we understand things like the get post failure rates, sort of how they're occurring by time. We understand, once again, the latency. How long does it take a device to update a digital twin? And then once again, we understand sort of device disconnects and what happens when and why did they disconnect as well. Third common test we do, we, once again, now we look northbound and we say, okay, let's run a test now to query, let's run a test to query to simulate a mobile IoT app, right? So we're simulating data queries at large scale against a digital twin. So it may be that at small scale, queries happen just fine, but imagine cases at production where there's a lot of querying of the digital twin happens. This happens almost always over HTTPS. Enterprises do this because it's important to know, obviously, how the IoT app performs. Because if you think about it, in the IoT world, kind of humans aren't usually involved, right? The human is usually not a device, right? The human is not a platform, right? But the human in this IoT equation interacts with that IoT app. And the human expects a good user experience. The human doesn't, like, once again, go back to the garage door, connected garage door example. Who wants to hit, your mobile app and see, is the garage door open or not, and have to wait 10 seconds to find out, to get a response on your app, right? No one wants that. It's a terrible UX, right? So we simulate this. We simulate this kind of experience with MightyPF to understand things like how often do queries fail completely? What's the average latency? What's that average query time from the point when the person presses the mobile device, to send out the query to actually getting the data back on their screen? What is that latency? And equally interesting is to know the data that goes from device to the digital twin in the cloud, then it is queried northbound from the application. What percentage of that information that's delivered to the end user on the mobile app is actually accurate, right? Was the sort of information that the digital twin update shared by the device into the cloud platform, Was it shared successfully, right? And so that's part of this test, is to understand the accuracy percentage of the data that's being queried from the digital twin. So a totally interesting and important test that impacts the UX of the end user. The fourth test that we do sort of starts us moving into the world of disasters, and this is the world of sort of IoT chaos engineering. Oh, and if you're interested in IoT chaos engineering, we've got some additional sort of research coming out on it. Check back on the Machnation website at machnation.com in the next couple of weeks. This is a totally interesting and completely undiscussed field. Chaos engineering is discussed all the time. IoT chaos engineering is not. But imagine what happens in this mass disconnect and reconnect event that we simulate. The first step is, imagine we're simulating 100,000 devices. Imagine that 50% of them disconnect from the IoT platform. We simulate that disconnect. Then we wait 20 minutes. So the devices are collecting their data, right? It's sort of collecting in its buffer, in essence, right? It's cached inside the device. And then at a point in time, we reconnect the devices to the IoT platform. All 50,000 devices try to reconnect to the platform all at once and stream their 20 minutes of cached data, right? Message ingest, updating the digital twin for the past 20 minutes. As you can imagine, enterprises do this because it's important to know how their IoT system handles a real world disconnect disaster, because it's probably the worst thing that can ever happen in an IoT solution. And it does happen for any number of reasons. And by doing this kind of test, we place huge strain on an IoT, an end-to-end IoT solution, and understand really incredible things like the number of reconnect attempts it takes for these devices to reconnect to the platform. Did it take one attempt? Did it take 2 attempts? Did it take 10 attempts, right? We also understand what percentage of devices never reconnect. And that happens as well with, platforms can basically sort of enter failure mode, right? And they sort of just, they sort of reach a point of sort of super saturation and can't recover. We also understand the time to reconnect. So does it take, under 1 second on average? And what percent of the devices reconnected in less than 1 second? What percent of the devices connected in less than 10 seconds? What percent of the devices connected in less than, 9,000 or 900 seconds, right? So these are really important metrics to understand. And finally, it's really important to understand, once the platform has reconnected these devices and the data is starting to stream in again through the cache of these devices, what is the latency under extreme stress in the software on the platform? So that's the fourth and really cool sort of chaos style test that we do. The last test, as we described it earlier, is a mass FOTA or SOTA update. So as we know, the FOTA and SOTA is one of the most important things that an IoT solution can do, right? And basically, it's a 2-step test also, right? So the way the FOTA and SOTA works is, and interestingly, this is a case of a test where the platform actually starts the workflow. The platform says to the device, we're ready to do a FOTA. The device says, acknowledges, and sends a message back to the platform saying, okay, let's go for it, right? And then the platform sends, I'm making this pretty simple, but the platform sends down its update. The device does the update, and if it's successful, it sends an acknowledgement, an ACK back to the platform and acknowledges and updates its digital twin. If it's unsuccessful, it sends an error message back, and also updates its digital twin. Okay, so this is really important. Enterprises do this to understand how sort of the IoT solution handles bidirectional stress, because a FOTA-SOTA update is a pretty stressful event on a software stack as well, and whether the stack can handle the FOTA and SOTA at scale. And also to understand how the IoT software stack handles this multi-step errors, right? Because an error can happen any place through this sort of back and forth communication between platform, device, and digital twin. And at the end of the day, if you can't perform a FOTA or SOTA efficiently, there's no way that you can keep the IoT solution secure. It's just not going to happen. This test is really important. So we understand, by doing these kinds of simulations and these tests, we understand sort of multi-step failure rates. Where does the failure happen throughout the phase of the test? And then the latency, how long does it take at each step of this sort of back and forth communication process? And can we figure out how to optimize the photo process to reduce the amount of time it takes? Because especially in the world where these devices are connected over a mobile network, over 4G or 5G, you get to pay for that. Generally in IoT, right? You get to pay for that bandwidth, right? So shortening lengths of time, shortening failures is really, really important. Those are the 5 tests that we do to make sure that these platforms and these IoT software stacks are highly resilient and highly reliable. The kinds of things that are needed, therefore, in performance testing software to do this, you have to be able to simulate extremely realistic IoT devices. I don't know how many times we deal with industrials, enterprises, and other companies that want to do testing with us, and they're using a testing tool that was built to do website testing. They're not simulating IoT devices, not even close, right? You can't do bidirectional communication. You can't start a workflow at the IoT on the cloud side to invoke a device to do something. You end up with sort of, if you start with bad test software, you end up with bad tests. Secondly, we need to have fast and easily repeatable test design. Every enterprise wants to do a test. They want to simulate 10,000 devices, right? Would be their first test, let's say. Then they want to sort of scale up to 20,000 devices, and they want to change around sort of what the devices are going to do. There has to be a fast, easily repeatable way to design these tests we use JSON templates, but in a templated based design. Thirdly, you have to be able to do a test that covers real world IoT message flows. Data ingest is a wonderful thing to be able to do in IoT, and we certainly test it. It's just the start, right? Being able to test for digital twin updates, for querying the digital twin from the northbound side, being able to do FOTA and SOTA, being able to simulate a DDoS attack is another really important unfortunately, it's a more typical IoT message flow than we want these days. It's important to be able to also, you should only have to pay for testing when you're doing testing. And that's not the way sort of it works with a lot of sort of legacy software today, but that's what should happen. Fifthly, you should be able to have extremely refined output metrics for every single action that a simulated device takes, every single message it sends. We should be able to have a unique UUID associated with that action so that we can drill down extremely deeply into output metrics to help us figure out how to tune these end-to-end IoT solutions. And finally, we should be able to have completely autoscalability in your test tooling, which another kudo to serverless design in something like AWS with MightyPF, right, allows us to have complete autoscalability. We don't have to worry about whether we're testing 10,000 devices or 1.5 million devices, right? All of that autoscalability is happening sort of behind the scenes. For us, it's even happening behind the scenes of the testing software provider. So therefore, it's happening behind the scenes for our customer. They don't have to worry about it either. Enterprises are using performance testing to drive resiliency and high reliability into IoT to make sure that it can meet their business continuity and disaster requirements. These enterprises are not going to be satisfied anymore in a post-COVID world with 1.9 of IoT performance. I really appreciate everyone being here today and listening to a little bit about high resiliency, high reliability, high performance in the world of IoT. If you want more information, feel free to contact us. Be happy to talk to you about performance testing, about IoT benchmarking, in the enterprise world. Thanks again.
Steve, that was absolutely brilliant. Thank you. And I'm sure everybody found that very insightful. I certainly did. It certainly got me thinking about a few things with certain platforms I'm affiliated with and what we do. So one of the questions I was thinking about was, I imagine in the way that we are with the adoption curve and stuff, that when you're talking about enterprises, you're talking about the platform providers rather than the buyers. Would that be correct?
I'm actually talking about the buyers. So I mean, these buyers have adopted IoT platforms. They've stood up IoT solutions themselves, right? Mm-hmm. And what we find, they call us because the solutions are not quite working right. They worked for POC. They worked for POC great, right? You want to put 10 devices on whatever solution they built, the software stack works great. But then they realize, okay, well, we've got to scale up to 10,000 devices. And they start to scale up and it's not working, right? Something's going wrong. Performance degrades massively.
Yeah.
And that's where we come in to help them, right? To test these solutions, to help their engineering and DevOps teams figure out what's wrong, right? And fix their specific implementation. Often it's not the cloud platform provider's fault, right? There may be nothing wrong with the microservices in the cloud platform, but oftentimes the implementation, the customer specific implementation, it may not have been done quite as well as it could have been. So
and when you were talking about user experience as well, from the app side, so the customer user side is the presumption that I took. What about the user experience of the enterprise and how they're finding to use the platform? Do you do any testing around that? So like as things evolve with technology, focusing on making sure more configuration, less code, so you can start focusing on the evolution side of things as well. Do you do that type of testing as well in what you guys do?
Yeah, I mean, so there's that two sides of the testing we do. One is on this performance and scalability side. The other side is on the capability and UX. So we do a lot of work with the the platform vendors themselves, right? Who offer these platforms to make sure that their UX and their capabilities are best in class. And what we generally do is we put their platform in our test lab, and we put a series of competitors' platforms in our test lab, and we go through a series of, I think we do 110 developer and operator workflows on the platform. We connect up to devices, we stream data, we build dashboards. And once we've sort of done that process, we understand sort of the UX and sort of can provide lots of insights into sort of how do you get a better UX, from the platform side.
Yeah, so I mean, like with the experience you've got, the access with the platforms and stuff, the insight you have is absolutely phenomenal, and I certainly learned quite a bit off you when we had a chat a couple of weeks ago. So thank you for that.
Thanks,
really
man.
appreciate it. Hey guys, we're running very close to 1 hour 30 minutes, which is a little bit longer than we have been planning for these. But Ricardo, Steve, Mark, absolutely brilliant talks. Brilliant for our first live stream. I can't thank you enough. Just a punt again in regards to IoT North, we've got our marketplace. Get your use cases on there, share your solutions. We'll market it for you. We'll drive customers towards you. And by all means, do reach out to Ricardo, Mark, and Steve for any help or engagement with them through. Thanks very much, guys. Thanks very much for your time. Really appreciate it, and look forward to catching up with you again soon. That's all for us tonight. Good night.